we'll start with the data that Hannah Mark gave us. And we were focused on the time, depth, and magnitude columns. And we started by graphing those out and then making a note list out of them. The note list is for C sound. We're using Blue, which allows us to make our instruments in individual tracks that play in this tab. And we're also learning synthesis from scratch. So we're working with different wavetables and additive synthesis, and we've made our way up through frequency modulation synthesis at this point. This is the assignment that, the second assignment that they made, and this is an example of the sonification of the Akutan data for depth.
Sorry, I think you're showing the wrong screen here. I'm seeing your attendance list, which I'm guessing is not what you meant.
Goodness. There we go. So let's try that again. So here's the data and made into a note list. Here's the project where they're creating their instruments, and then the data as a note list. And this is the baseline of mapping the depth to pitch and the magnitude to amplitude, and pitch is scaled just across the notes of the piano. And then Kasra is the first student to present. This is the midterms that were due last night. And so now they're trying to map the data to more interesting synthesis and music parameters. And I'll play Kasra's and then he can come on camera. Kasra.
Do I go forward?
Yes, please.
Okay. Hello, my name is Kasra. I'm a first year here at Virginia Tech. And for my code, I wanted to experiment with how melodic it could feel, and how musical it could be. I thought a lot of this was gonna be questions, so I had some questions and ways I was thinking about it prepared. But for my code, I was thinking you have the beep boop section of the beep boop default music, but how can I smooth that out? So one of the things I did was I made it sorry, I'm nervous. I made it pentatonic. So it snapped the note. It snapped the frequency to be closest to the note.
Doing great.
Thank you. Snapped the frequency to be closest to the pentatonic note. And then the drone was very helpful in creating this bass, creating something you can connect to and continue to feel. And it's the final kind of aspect. There's a lot of other things, but the final aspect that I think was important was adding a lot of reverb and having it so that's the reverb made it feel more wet and like oceany, which was where the data was coming from. So I was like imagining and looking down into the ocean and like feeling the different like depths, and that was my intention behind like making it very, very wet. I think it was like 70%, and letting the sounds like fuse into each other, rather than it just being like a note, 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 note. Yeah, a big like cathedral level reverb.
Great.
Yeah. Now can I ask like questions, or is that not?
Kate?
We're going to be doing most of that in the breakout room. And what we wanted to do first was just get through just you presenting about your sonification and let the whole group hear it. And I really want to thank you, Kasra, for being not only the first joining this first effort to try out a new format for us, but being the first person up. That was really great. I could have gotten on, I can see now, I could have gotten on and done a little bit of coaching with you guys ahead of time or let you practice with me. So you're already teaching us a lot. And this is the greatest group of people to present to new projects. We have been supporting each other for over 5 years now. And so don't sweat this at all. I'd love for you to just tell us a few more things about, go back and review for me what the data was. And what was your particular audience that you were going for? And then tell me a little bit about any challenges you had.
Yeah. A little bit.
Yeah.
Jayden, could you move your head so that yeah, thank you. So I need to see this tab down here.
For the data, I was treating the depth as frequency. And I scaled it down massively, like, and made it in like okay, so like this is my lowest note, this is my highest note, and then we're playing everywhere in between that, which I'm guessing, not guessing, that reduced a lot of the actual distance, but it made it feel more musical. I was imagining this would be sort of like you're in a museum, that's like a museum exhibit, where there's this ocean, kind of like, what was the research, what have we learned, this beautiful thing, and then you're like hearing this as you're learning about it, because I wanted it to feel very, very oceany.
Okay, thank you.
Then, yeah.
Oh, just let us know about the challenges, and then I'm afraid I'm gonna have to move on.
Cool, sounds good. And then some of the challenges I had, one thing that I learned is, this is my consistent challenge, was it just kept sounding like abrasive, and I wanted to feel more musical. Not like music exactly, but how could I make the data? So one thing I realized was using by compressing the data, and scaling the, some of the notes were very loud, some of the notes were not loud at all, but the notes that were really loud were like bang. So I wanted to bring that all down, and I wanted to kind of have them blend into each other. Yeah.
Cool.
Jayden, what can we hear from you?
Come on up, Jayden. And I will share screen again.
And Hannah, confirm, is this your data that they're sonifying here?
This is data that I shared from the Alaska Volcano Observatory.
Cool.
Okay, so there was that. So admittedly, I did not have that much time to work with, and I put some constraints on myself to only what we learned. So though I tried to be more like experimental with what we have, like such as oscilles, such as the K envelope, the ADSR, and the fades. So I started to try to like combine some of those to try to make like my own kind of effects to make the sounds less blippy and more kind of like fade in, fade out. But there was I spent a lot of time trying to fix the bugs that kind of went out of the range of the amplitude, trying to mess with them. But eventually got it to a point where I would have each of the amplitudes will go up and then go down. And I've also made it so that they're more saturated, so you can hear them a little bit more varied between each other. So I ended up making a sound that's kind of more like a lasery sound. So there's kind of like, you kind of get the feeling that each of them are kind of like passing by your ear almost, whilst making them less harsh, is what I was trying to do. But so there's that.
Okay, and can you tell us who, did you have a particular audience that you were designing for?
I didn't have an audience because the way I do like music or sound in general is that I tend to not necessarily have an end goal, but experiment with it, and then if I find something I like, I kind of just run with it. So I didn't really have a goal initially. So I kind of just like build on
And
it.
in the end, did you have a sense of the of what was coming out of the data for you?
Admittedly, not really. Because after finding that sound, I wanted to try to get a little bit more to what my peer had, to have them lead into each other and try to get it more melodic. But I couldn't really think of anything that would achieve that.
Good morning, everyone. Good afternoon for me. I'm connected from the north of Germany, and today I'd like to present my project to you in the hopes that we can maybe collaborate on making it more useful and pushing it out to the world so that people can actually benefit from it. For the past week, I've been looking at glucose charts in CGM apps. I'll explain a little bit more about that in a minute. And I want to make them accessible through sonification. So why blind diabetics? Well, because blindness and diabetes are strongly connected. According to a recent study, there's about like 3 million people who are either who are vision impaired due to diabetic retinopathy, and about 1 million who are fully blind worldwide. So yeah, there's a lot of them, and also historically their care hasn't been great. Like talking glucose meters are a thing that's like 10 years old, and CGMs that actually can speak their value through them from their smartphone, that's kind of recent. So what's a CGM? A CGM just stands for a continuous glucose monitor. That's pretty much what they do. So you have a sticker, you attach it to your body. It has a sensor under the skin, and that measures glucose in the interstitial fluid and sends the data to your phone. You get one reading every 5 minutes, and it's much more comfortable and convenient than pricking your finger whenever you need to. And also the data is just complete. You can see everything that has happened every 5 minutes and not just one event, which could be incredibly helpful for blind users. They have done a small study where they tested with some blind patients. They gave them a G6 on an iPhone and showed them how to read out their current value with Siri. And that has already drastically reduced the amount of severe hypoglycemia events, which is low blood sugar. And yeah, so I'm essentially saying access to values over time, not just your current value, would help users understand how their behavior affects their blood sugar, and hopefully result in better long-term management and better quality of life. Yeah, so 8 years ago, I arrived at this issue kind of accidentally. I have a blind friend that's also diabetic, and I happened to care for him. We set up his new CGM device, connected it to his iPhone, And then we hovered his finger over the graph, and it literally just says twin graph. It doesn't give the data, it just reads those two words. In 2021, Apple has released already an easy way to make charts accessible, which means that surely the new G7 system has fixed this, right? All right, I guess. Let's see if audio is actually transmitting, and do interrupt me if it is not.
I'm not hearing any audio yet.
Oh, that's a bummer. All right, I just explain it then so that we don't lose too much time. It's a person, and she's showing off the new graph and how it sounds in VoiceOver, and it just says 3, 6, 9, 12, which are the labels for the x-axis. So there is no access to it for blind users. So yeah, what I would like to do is to make the glucose patterns and history accessible to blind diabetics through touch and sound. And I'd like to achieve that by making an iOS app with custom sonification that's built for this specific context. Apple already has in the 2021 accessible charts, they have already done something similar. They have made the chart accessible to VoiceOver. And if you go to the rotor, there is a sonification feature. However, that is not applied to the context of glucose. So that means it really just has the pitch mapped to the value and nothing else. And it also doesn't sound great. I think I just heard the adjective abrasive, and I wrote it down because it's very fitting. It's just the pure sine wave. It's not something that you can check in a full restaurant, for example. So I'd like to adapt what they have already made to the use case of monitoring your glucose. Last week, I prepared this presentation, and I didn't have anything. I was looking for sonification experts and an iOS app developer who can help actually make the app. And then I sat down on the weekend. I really just wanted to make a small proof of concept. And Claude was really quite helpful. And I managed to implement most of what I wanted. So I have an iOS app now that can access real user data via Apple Health. It can access Dexcom Share glucose values. The charts are fully accessible. I've even made a custom, a little bit shorter version. The sonification feature is fully working, and I have a beta version up on TestFlight. That means what help I would like from you has kind of changed. I would like a professional review of the sonification I've built, and ideally some support maybe with user research. I'd like to share a little bit of the details about the sonification. Apple has AV Audio Engine, which gives us low-level access to audio synthesis. We can map it. We can apply a lot of different effects to it. For now, I've just, if you are above the range, then there's a vibrato applied to the sound. And if you are below the range, there's a tremolo. I guess I'll share a YouTube link after this. And another thing that I've built just based on some interview where someone shared with me that blind users are already uploading screenshots of their constant glucose monitoring apps to ChatGPT to get like a text summary of it. I've tried it. It's really not reliable. It uses visual data, which exists in number form. So I've tried doing it on newer iOS devices with local LLM Apple Intelligence, which I'm not really happy with it. I've built another thing which does it with rules. So yeah, that's another area of work that if somebody is interested, I'll be happy to collaborate on. Yeah, so in summary, I could use a bunch of support with user research and testing. We can iterate on the sonification. We can make it sound more pleasing. We can make it based on actual scientific evidence on what works well. And maybe there's some opportunity for improving the chart to text, improving it for the local AI and for the rule-based version. And ideally, once I'm done with this project, I'd like to have it publicly released in the App Store. I'd like to release it as an open source project. I'd like to prepare localization and also hand it off to community governance. Yeah, that's everything. There's a link to the test flight if anyone wants to try out the iPhone app. And yeah.
Okay, we'll make sure.
All right, I'll be the one sharing my screen here, so just take just a moment.
And if you'll both introduce yourself real quick.
Yeah, we have that built into our slides actually. So,
Good.
all right, are you seeing my screen here?
Yes, I am.
All right, so I'll begin. So we're going to be talking about our class internship project ideas. My name is Micah, and Nietzsche will also be presenting here. So I am a student at the University of Louisville. I'm a math major, computer science minor, and my interests are accessibility and STEM and astrophysics. And I'd like to do grad work in computational astrophysics.
Okay, hi, my name is Nitya Sharma. I'm a junior at East Chapel Hill High School in North Carolina. I've been doing data sonification for like the past 2 years. I'm interested in STEM accessibility, data visualization / science, and also astrophysics.
The summer structure is actually going to be intentionally very loose because we want to allow for creativity to flow, and we want to mess with tools, spend time experimenting. We want to play with various sonification tactics and grapple with challenging questions. This is a very patient model of learning because we're just spending time really grappling with questions. And one question that we're going to be consistently asking ourselves is it effective? Are we allowing these sonifications to are these sonifications actually empowering blind and low vision students to ask really good questions and interrogate their own data? So we have a very heavy emphasis on feedback during the software development process throughout the entire summer. So that's one of the things that we're definitely going to be looking for, people who can give that constant feedback.
So our goal is to explore BLV accessibility by using audio to create proof of concept, core astrophysics concepts, and a visual scientific workflow into projects.
Chuck, can you speak a little louder?
Oh yeah, sorry. So our goal is to explore BLV accessibility by using audio to create proof of concept, core astrophysics concepts, and a visual scientific workflow into projects that lay groundwork for more advanced and polished work in the future. Like Micah said, it's a very loose structure, and we're really aiming to familiarize ourselves with a wide range of sonification tools and techniques that we can use to better serve the community.
So we have, several project ideas in mind that we want to really dive into. And one is asteroid detection. Given 9 to 10 images that are in the same location in space, we can that has an asteroid going by. We want to allow a blind or low vision user to independently interrogate these images to find and mark each of the spots where the asteroid is, and then create a light curve from those images. And one idea that we have that would be pretty interesting to explore is using an iPad interface that allows the user to parse through the images or the differences between each frame, and then to be able to detect each of those and then mark them somehow. So there are a lot of challenges here, but it would be a very interesting project to explore.
Our project number 2 is HR diagrams. So an isochrome is a curve on an HR diagram that represents a population of stars in the same galaxy but with differing masses. Isochrone mapping is kind of a method that matches the colors or surface temperature and sizes of stars in a known galaxy to estimate that galaxy's age. Isochrone mapping is basically when we try to approximate that isochrone. We will be conducting this project with the use of Astromancer, and which will significantly help our project because it provides theoretical isochrones and tools to compare observed data with model predictions. And this is really helpful because it can help us identify the best fit curve, overlay different isochrones, and kind of translate the entire fitting process into sound so users can hear how well the model matches the data. Our goal for the project is kind of to build a proof of concept sonified HR diagram, which kind of audibilizes the whole process of isochrone mapping.
And we also want to take a look at learning modules and ask the question, how can sonification be utilized as a tool for teaching students about astronomy and physics? Physics students will likely have to take like a modern physics class that has 2 pretty important concepts in it. One would be the Lorentz transformation, which is for which describes special relativity. It's the backbone of special relativity, and it tells us how to change the Newtonian laws of physics to match Einstein's theory of relativity. And another is Fourier transforms that find their way into a lot of areas of engineering and mathematics, but also in physics because of the wave property of electrons. And it allows us to interrogate that wave property using sonification to teach these concepts and to prepare students for these modern physics classes might be an interesting challenge.
Okay, and last but not least, our project number 4 is a sonified planetarium. So we're creating a sonified planetarium experience to let users hear astronomical structures, celestial motions, and be able to navigate astronomical scenes without relying on visuals. And we will be conducting this project with the use of OpenSpace, which is an open source astronomy visualization software that displays data in 3D. It will significantly help us create a sonified planetarium by providing a 3D model, which will definitely aid us in sonifying the whole, planetarium. So.
And we do have a couple additional project ideas like sonifying astrophotography filters. But we also want to know if you guys have any really complicated data that you are struggling to find ways of accurately and effectively sonifying. So if you have any data like this, let us know, and maybe we can experiment with that throughout the summer. And we're also thinking about tool consolidation the whole time. If there are functions that we're constantly using in our sonification process, these might be useful functions to share with everyone. So maybe developing a small Python library of sonification techniques. And then we want to hear from you all if you have something that might be challenging to sonify or some interesting project in mind. And then another way that we're seeking guidance is feedback. We want to implement feedback into basically every stage of our software development. And we want to make sure that our tools are accessible, effective, and easy to use. They're enjoyable, and do these sonifications clearly communicate the data. So thank you.
Yeah, so this sonification is the sound of ocean heat energy, and it takes data. I can't see my tabs because of the zoom bar at the top, but let me here we go. It takes this data from NOAA, which is the amount of heat energy absorbed by the world's oceans in the top 700 meters of all of the oceans in the world, and it's divided into every quarter. It is like a large amount of heat. Like the units are 10 to the 22nd joules, and like I think 10 to the 21st joules is let me start this. Oh, zettajoules. Okay. Yeah. So the way it works is it just marches. It's extremely quiet right now because it starts in 1970, where there's like 20.63 zettajoules over the amount of heat energy that was in the ocean in like 1955. And the way I'm gonna stop this for a moment so I could talk. So the reason I went with the way I decided to represent the magnitude was through chord density, or I guess you could call it pitch density, because I wanted people to just get a sense of the journey. Like you could sum all this up in by saying that the amount of ocean heat energy went up by quite a bit or something like that, but I don't think that captures the whole story. And if I did like a typical stock market sonification with just pitch, it'd go on quite a while and get quite high, or you'd have to just have like the pitch changes be very subtle. I was also reading this this interesting paper. it's about, I could link this later, although if you've already been doing data sonification, you might have found this in a search, but it like went through, like, it took some users and it tested them, and like it tested certain assumptions about what people perceive when they hear data sonifications. And there was a group of people that thought, like, if the pitch goes up, things are getting smaller. And there's some people that couldn't tell two pitches apart. So I felt, and I've sort of experienced that myself. I'm a musician, but I can't always tell, like, whether something is necessarily higher or lower without like a lot of context. But chord density is something that I feel might be more accessible, and I'd like feedback on that. So what I did was I tried to represent higher magnitudes with denser chords, with more pitches played at the same time. The one problem is if you use traditional chords, right, there's, you know, in a, like, an octave divided into 12 pitches, you could only go so far. So I needed more divisions of the octave. So I used something called the tonality diamond, which is kind of a mathematical extrapolation of just intonation. So, I mean, you probably, I don't know, you may have heard like an octave, right, plays at twice the frequency of the root, right? And like in just intonation, there's like all these nice relationships. Like the fifth is 1.5 times as fast as the root, and you know the major third, or sorry, that's the fourth is 4/3, and there's a bunch of these. But if you keep going, you get into things like this relationship. So the denser your chord is, I'm just going to bear with the noise. You can end up with something, right, that sounds more dense than one note or two notes. And eventually approaches noise. So this piece tries to use that. So again, here in 1970, things are pretty quiet, but I'm gonna skip forward here. How far in time are we here? This is 1974. Okay, that's not very far ahead. So there is, I hope, I don't know if you can hear over Zoom, but there is a difference between this and I hope there's a difference between this and like 1970. Let's move forward a bit more. And then let's skip ahead a lot. So here in 1991, it's a lot denser. Like this is how much of the tonality diamond is being used. That's not that many pitches. This represents 89.92 zenitones. If we skip forward here. Yeah, like there's limited time, so
we actually couldn't hear what you were saying when all the sound was playing.
Yeah, Jim, we couldn't hear you when you're at the end there, the last couple. because
Okay.
the sonification was very loud volume.
I'm sorry.
That's okay. That's
Um,
okay. We just didn't want to miss what you had to say.
Basically, what I was just saying is, hopefully things are noticeably different to the listener at that point. Chords are very dense; they're very noisy, and the hope is not only can they hear the difference between that and say like something much an era where things were there was much less heat energy, like 1980. Hopefully they get the. I'm hoping they get the story of the change. I couldn't just sit here and play this for 15 minutes because I only have 7 minutes here. But you'd see how it gets from like 1970 to here. Is what I was going for, and I hope to get feedback on that. Yeah.
Okay, we're good. We're gonna have to wrap you up, and I'm going to create these breakout rooms now.
Yeah, holy cow. So we just got the tip of the iceberg because there were about 20 different sonifications that were submitted. And so we got to hear about 3 more. And it was fun kind of ping pong between the students and Hannah and learning a little bit more about the data structure. And then Hannah, do you want to just jump on and just share a little bit about your experience of hearing all of these different sonifications of your data?
It was so cool. I am excited to hopefully hear the rest of them at some point, but the ways that the students took this data set and ran with it, I mean, I didn't know what to expect, but I probably wouldn't have expected any of those things. So that thrilling, honestly, to get to hear it that way. Thank you so much for sharing it.
So it was a nice learning experience for me as well, hearing a little bit more about the nature of the data set from Hannah, learning about, for example, 10 kilometers is a depth at which beneath that you understand that, oh, this is a very subsurface, it's deep below the surface earthquake, and that's kind of like a little category of its own almost. And so there are different ways of thinking about filtering the data, learning about just kind of different things that are important with Hannah and the way that she thinks about the data. And then also learning from the students, what did as you came to understand FM synthesis, as you came to understand wavetable synthesis, but then also learn about it through the medium of sonification, kind of like what was that co-learning experience like for you? It would all happen very quickly, but a lot of the students had little epiphanies about the data sets as they were generating the sounds, which was cool.
And next week, Amy presents to our class and we start working with her data.
Yeah.
Oh, that's awesome.
Looking forward to that.
Okay, anybody else from that group or anything else to wrap up on that one? And if Robert, if you'll stick around, if you can, when it's done, I'd like to hear any feedback you've got on how we can structure this for April even better.
Sure thing. Charles, any last thoughts?
Okay, well, Virginia Tech, again, thank you for being part of the experiment. And with that, we're going to go on to Matt, room 2 with GlucoSound.
Okay, so so Mon explained more about the project, and it's extremely well developed. Like a lot of the things they thought they need support for, they managed to accomplish very quickly. So it's very impressive. We heard a sample, and it's I think it's great. It's pleasing. It's clear. So it sounds like next steps are testing. It hasn't really been tested with blind users much, except for discussions with your friend. But we also talked about the potential benefits for sighted people, in particular children. I think Kathy made an interesting point about how it might be more impactful and a better learning experience for kids rather than visual graphs, because it's already something happening in time and it connects to what they're feeling, to help them understand how I feel when my readings sound like this might be more direct. So I thought that was interesting. A lot of potential here. Any other thoughts you wanted to share, Mon, or anybody else?
This is Amy. And I just wanted to ask the presenter to reach out to me. Maybe Anna, if you wouldn't mind sticking just while I'm talking, stick my email in the chat. Because I would be interested in having you present. I belong to an outside group. It's called the Visually Impaired Boston Users Group. It's a visually impaired group that are very tech savvy, and some of them are diabetic. They're very interested in all kinds of detection methodologies such as you've developed, and they would love to hear what you've developed, and especially if you have an app that's going to be publicly available soon. So if you could reach out to me, and I'll try to arrange for you to give like a 15-minute presentation at some point.
So sure, I'll send you a mail right after the meeting.
Okay, thanks.
And I just wanted to mention also for our group with the GlucoSound, the creator of the app was saying that he's not a scientist or an engineer, but obviously he has an interest and a passion, and he's doing the work and also having these dialogues. So don't box ourselves in with labels.
Thank you, Adrian. That is a really great comment. So what about Summer at Glass? Jess, what you got?
Hey, sorry, you're on my other screen. I love astronomy sonification. We had a good chat about some of the ideas the guys have got, and we ended up getting into like the asteroid idea and how that could sound, some different ways to kind of place that. I would love to hear more from them in general about how it goes over the summer. Obviously, as this is more of a summer project. Mika, did you have anything that you took away that you thought was useful? Or Nitra?
I just really appreciated hearing the different perspectives and really thinking about that question of like, are our sonifications allowing the public to really understand the data, and is it like giving them the tools to trust the data? That's a question that I hadn't really thought much on, so I appreciated that.
Thank you. Yeah, I'm glad you took that away, because that comes up in astronomy a lot, and it's really, really useful as an inroad for the public.
Okay. Anything else from room 3?
No, it was just cool, and I think with the astronomy data, there's always a challenge of trying to, as Jess said, convey something that's already beautiful, and try to avoid just adding some icing to that cake, right? Because it is already beautiful. But I think with the projects that they've got on the go, I think would be really interesting if they can crack them. So yeah, good luck. And Mika, you've got my email address, so we can carry on talking about it. So.
Okay. All right. Excellent. So our last group, the Sound of Ocean Heat Energy, room 4, Ruben and Amy.
Amy, please. Do you want to?
Oh, well, I'll just kick us off. Yeah. We talked about some of the sound design, which I think everyone agreed was very effective, but with some tweaks, could it be even more so, some minor tweaks. We talked about how to make it accessible to blind and low vision people. We talked about the audience being, general museum goers, and how to keep them engaged by making the sonification shorter. It's 15 minutes now, and probably 5 minutes is the maximum you would want to go. And also, Jim had great ideas about making it interactive as part of an exhibit with a slider, some way to jump around in the sonification and listen at different times rather than just having to listen to it serially, which I thought was a great idea. Do you want to add more, Ruben?
I think you pretty much nailed it. And I think Jim has a very mature project. Also talking about how to test a bit his approach with other users and also with visually impaired users to see how he can adjust some of the intermediate levels. But we think that he has a very, very cool project.
Well,
yeah. I don't know if sorry, Kate, I don't know if I said this, but we refer Jim and anyone else who's interested to the Accessible Oceans website, where John Bologna, who had to leave a bit ago, and our other Accessible Oceans team members have posted some particular small, what do they call them, blog posts with, some of them are quite short and quick, and like, here, this is one way to do tick sounds. This is one way to keep track of time during a sonification using a voiceover. So there's some techniques that we tested and posted information about there. I mean, we're not the first on some of these by any means, but it's a resource. accessibleoceans.hui.edu. Maybe, Anna, you could put that in the chat. Thank you very much.
Thank you. And thanks for the reminder on that, because that's one of the things that is going, when Micah's here this summer, is we're going to see what we can do about getting more of this up on the website. We have lots of things written, but it's not collated in the way that is good. So, and there's so many great stuff out there. So, and Micah does have a put together a just a Google Doc with all sorts of things to point the core classes to. So Virginia Tech and John's class has got access to a lot of the stuff we've done here. So thanks to Micah's quick typing. So with that, and I want to thank everyone for coming and making this as awesome as it was. And we are going to